Hi guys, it is Friday afternoon and I'm going to try and do some of these homework problems with you. I'm not going to do all of them as usual. I'll try and do several just so that you can get the feel for them. Here in number 1, and notice this is 12-2 practice. So here's what we want to do. We're looking at this shape and they tell me up here that this circle is congruent to this circle. They are the same size circles, like we took one and we copied them. So I also can look here and I look, you know what, it looks like QP is congruent to AB. So if those are congruent, that's telling me that this arc AB is congruent to this arc PQ. It's also telling me that this angle is congruent to this angle. And then I have vertical angles that are congruent, which means that this arc is congruent to this arc, and that this side is going to be congruent to that side. So you can see, just by knowing that one thing, we're able to make a lot of conclusions. I also know that this diameter is going to be the same as this diameter. So that also means that the radii are congruent. So once you know that there's a piece congruent in both, they're congruent shapes, and now I've got one congruent inscribed shape, then we can kind of start messing around with it. Here again, we have congruent. I want you to write everything you think is congruent. Give them some names. This is a great activity for practicing arcs, for practicing chords, for practicing central angles. I want you to kind of think about what is going to be congruent and what isn't. Look down here at number 3, or maybe you would prefer if I did 5. But I want to do something here. I want to make sure you realize that these 3's are talking about this piece right here. This piece is 3 and this piece is 3. Okay? X is not attached to that and 3 is not the length of that chord. 8 is talking about this side. Okay? I just want to make sure you get that, because I think if you don't, it gets a little bit confusing. Let me show you here. This X is referring to, hang on a second, I lied to you. This X is referring right here to this piece. And this 5 is referring to that piece. And those arrows are not there. So hopefully you can kind of look at that and figure that out. Same thing here, 4.9 is talking about that. 6.3 is talking about that one congruent piece. And X, of course, is this whole side. So let's do one of these. I think we did some of them during 5th period, but none of them are very difficult. I know that this is 4.9, and these two are marked congruent, so this is 4.9. So these chords, this chord is the same distance from the center as this chord is from the center. Okay? Notice that the diameter is going right to that center, or the radius, or this measurement about how far down it is. It's going to the center of that line segment. That's an important piece to know as well. So we would know this is a right angle because it's the same distance and it's bisecting. So now here we go. I know that this is going to be congruent to this. So, oh wait, these are equidistant. So if this is 6.3, this is 6.3, and what's the length of this whole thing? 6.3 times 2, which is 12.6. Okay? And you're going to do the same kinds of things over here on 3 and 4. Can you see that pencil very well? It's not showing up real well. Let me make sure. Maybe I'll break out the marker here in the colored pencils. Okay, here's number 6. In number 6 it says that AC is a diameter. Well, here's AC. Okay? It tells me also that ED is congruent to EB. This is congruent to this. What do we know? Well, if I have two sides congruent, what kind of angles do we have? What kind of triangle is that? That triangle is, now this is not an inscribed triangle because this vertex isn't up here. But we do know it's an isosceles triangle. And if it's an isosceles triangle, I know a lot of things. I know this angle is going to be congruent to this. I know that this side is the same distance from here, and that chord is being bisected. So that means this is going to be congruent to this. Well, let me put 2 marks because it's not the same. Oh, where'd my color pencil go? Pick a different color. Sorry. This is congruent over here. So if those are bisected, I also know that this arc is going to be congruent to this arc. Now this is asking you to write out a proof. I don't want you to write out a proof. I just want you to mark up the picture. So, or just kind of think about the conclusions. Look here at number 7. It's the same kind of thing. It tells me that in circle D we have a diameter, but they don't even actually tell me that that's a diameter. I know because this is the name that tells me this is a center point. Okay? And it also tells me that ZX is a diameter. It tells me that ZX is perpendicular to WY, which they've already marked there. Well, if it's perpendicular, what does it do? If you can't remember, hopefully you can pull out your notes and you can look. Oh, look, what we talked about today. We said if you have a chord that's perpendicular to a diameter, then we know that we're going to have these be perpendicular. So we know that this is going to be congruent to this. Okay? I also know that this is going to be bisecting that arc. Okay? Let's look at these down here. Number 8. That pencil's lead is broke. I don't want to use that one. It wants us to find the value of x to the nearest tenth. Well, this chord is perpendicular to this. What does that tell me? That this is congruent to this. So how long is each of those? 7. So I know this side right here is 7. This is a diameter. Here's the center. This side is a radius. How far is it from here to there if the diameter is 18? 9. That's a right triangle, guys. X squared. This is my C because it's across from that right angle. Okay? X squared, and I'm going to call it plus 7 squared equals 9 squared. 7 squared is 49. 9 squared is 81. Subtract it. What does x squared equal? (32). When I take the square root, I know x is 5.7. So that's the length of that line segment. You're going to do the same thing over here. This whole line is 10. Don't forget, this is just a radius. Anywhere I draw that around here is going to be a radius. So I can draw it here as well. I know that's the same distance. Now I've got a right triangle. This has been bisected. I know that because of the perpendicular. So this is 5. Right there is your problem. Don't panic about this. Find x second. Call this piece y, because we'd have two little y pieces. We can find the y and then add them together and get our x. Look at number 11. This one you may think is a little bit tricky, and I'm inclined to agree with you that it looks hard until you pull this triangle out. My triangle looks like this. 15, 3, x. I know every single student I have can find the length of that. It wants to know the radius of this circle y. That is the radius. It's the distance from the middle out to the edge. So guys, it's not anything more than the Pythagorean theorem. I'm not going to solve it because I know you all can do that. You don't need to do 12 and 13 are proofs. Let's not do those, but let's talk about them. They give you a lot of givens here. They tell you that this HK is a diameter. So here's my diameter. They tell me that arc KL is congruent to LM, which is this arc, which is congruent to this one. So all those arcs are congruent. and it wants to know, can you prove that we have two congruent triangles? Well, if I have two congruent arcs, do I know that this side is going to be congruent? This is a chord, and this is a chord. And they intersect or intercept a congruent arc. That means that they have to be congruent. So look at this. If I draw this triangle out, what we have so far, I know I have a common red side between both of my triangles. I know I have a blue side that's congruent in both. Do I know anything else? What kind of a triangle is this? Anyone? No one's in the room. This is an isosceles triangle at least, so I know I've got another pair of angles congruent. I also know that where a diameter intersects this chord, so I know I don't want to use blue. I'm sorry, guys. I want to use green here on this angle so I can show you congruent. I know this is going to be congruent to this. Do we know that this is a right triangle? Well, if it's an isosceles triangle, we're pretty certain that this has got to be bisected here, because I know it's the same distance. So this is going to be congruent to this. So we are going to have another congruent side, because if this is an isosceles triangle, I know that this diameter, these two ends are going to be the same distance apart. So we would have side, side, side congruence. Okay? Let's look at, I don't want to go through 13. I don't want to waste the time on that. Okay? So now let's look at another problem here. NO, this number 14. Now notice that 14, 15, and 16, 14, 15, and 16 are all talking about this same figure. So I would tell you to do one of two things. Either draw this 3 times or use pencil on it. Since I'm only doing one problem, I'm only going to mark the things that we know in red. I know that this is a chord, and I know that this is a chord in both of them. Where they intersect, it tells me that they are perpendicular. I know that's a right angle. Okay? Because this is a radius bisecting that chord. So, knowing that, I know that I can draw a radius here. Let's pick a different color. I'm just going to pick green for right now, and we'll just dry these out. And right there, anywhere you draw a radius, it's great if you can draw a radius to help yourself make a right triangle. So let's draw an example of our right triangle down here so we can write the information for this specific problem on it. Okay? Now let's label our shape. This is going to be N, P, and this is, we don't know the name of this point, so I'm just going to make a dot, because they didn't give me a name for it in the original picture. Okay? So if NO is this whole thing, and this is cutting it in half, what do we know? We know that we've got to take that in half, and that's going to be the length of that side. We know that PQ is 8. Right here, it tells me it's 8.